So today, we're going to dig into some pretty shocking new science that uncovers a violent secret about the star at the very center of our lives, our sun. For pretty much all of human history, we've looked at the sun as this steady, life-giving force. But what if that's a dangerously incomplete picture? What if our star has a hidden, much more violent side that we, modern humanity, have just never seen? And for a long, long time, this idea of a perfect, blemish-free sun was a core belief. That was first really challenged when astronomers like Galileo pointed their newfangled telescopes at it and saw, well, dark, shifting blemishes, sunspots, messing up its supposedly perfect surface. But that discovery, that was just the beginning. The real revolution in our thinking, though, that happened much more recently. In 2012, two completely separate lines of discovery came together, and they revealed that our sun is capable of eruptions far beyond anything we had ever imagined. Okay, let's get into this because it really does play out like a cosmic detective story. And it starts not by looking up at the sky, but by digging into a really strange anomaly found right here on our own planet. You see, the first shocking piece of evidence didn't come from a satellite or a telescope looking at the sun. It came from looking deep inside Earth's own historical records. So you've got scientists studying the rings of an ancient Japanese cedar tree, and they find something just bizarre. In the single growth ring from the year 775 AD, there's a massive, totally unexplained spike in carbon-14. That's a radioactive isotope created by high-energy cosmic radiation. I mean, this spike was so enormous, so completely off the charts, that the first theories pointed to these really exotic, distant catastrophes, like a nearby star going supernova. But the real culprit, as they'd soon find out, was much, much closer to home. It was our sun. It had unleashed a storm of high-energy particles so intense that it left a permanent radioactive scar right here on Earth. We now have a name for this, an extreme solar particle event, or an ESP. Scientists can actually track these ancient solar tantrums by hunting for what are basically cosmic fingerprints. See, when a huge burst of solar particles smacks into our atmosphere, it creates specific isotopes. Carbon-14 gets absorbed by trees, and things like beryllium-10 get locked away in polar ice. They are perfect little time capsules of the sun's most violent moments. And by digging into these natural archives, a pretty startling history has come to light. We've now found evidence of at least 7 of these massive solar storms just in the last 15,000 years. Now, they're not on a regular clock or anything, but they seem to happen roughly once every 1,000 years or so. And the sheer power of these things, it's just staggering. The energy released by these ancient storms was up to 100 times greater than the strongest solar event we have ever measured with modern instruments. It's like we've only ever witnessed the drizzle, not the real hurricane. Now, get this. At the exact same time scientists were digging into Earth's past, a totally different team of astronomers was looking outward to other stars that are basically twins of our own sun. So this gave us a second, completely independent way to check this out. One group was looking down at the rings and trees and layers in ice. The other was looking up at the stars in our galactic neighborhood. And they were both trying to figure out our sun's true potential. And this is such a brilliant way to think about it. It's basically a clinical trial for our sun. Instead of waiting thousands of years to see if our sun does something rare, you can just watch hundreds of thousands of similar stars for a few years and get a pretty good statistical snapshot of what's possible. And what did they find? Well, they found absolutely astonishing, powerful eruptions they called superflares happening on stars that were, in pretty much every other way, kind of boringly similar to our own sun. Now, this is a really crucial point. You gotta compare apples to apples, right? Early on, the data was a little skewed because they were looking at stars that were younger and way more active than our sun. But once scientists filtered the data to only include stars with the same temperature, rotation speed, and variability as our sun, well, a much clearer and more worrying picture started to take shape. So this is where the story really comes together. We have these two extraordinary phenomena, these extreme particle events recorded right here in Earth's geology, and these superflares seen on distant sun-like stars. The big question was, are they the same thing? This became the central mystery that scientists had to solve. Is an extreme solar particle event simply what we feel on Earth when our very own sun lets loose with a superflare?
And the answer, it turns out, is a resounding yes. When scientists plotted the energy of all these different events, from the small, modern flares we see all the time, to those ancient ESPs in the tree rings, to the superflares on distant stars, they all fell along a single predictable curve. It shows they're all part of the same physical process, just at wildly different scales. Small flares are common, mega flares are rare, but they're all playing by the same rules.
So the verdict is in. The evidence from both Earth's past and from distant stars points to the exact same conclusion. The laws of physics that govern our sun absolutely allow for eruptions far, far larger than anything humanity has ever recorded.
So, what does all this ancient history and distant astronomy actually mean for us right here, right now? This is the crucial takeaway. And here's why it matters so, so much. While our atmosphere is great at protecting life on the ground from the radiation, our modern, tech-heavy civilization is incredibly vulnerable. An event on this scale could destroy most of the satellites in orbit, crippling GPS, communications, and it could trigger massive, continent-spanning blackouts that last for months. For decades, our entire idea of a worst-case scenario for a solar storm was based on what we'd actually measured in the last 80 years or so. We thought we knew the sun's limits. But the silent archives, the ones stored in ancient trees and ice, they tell a very, very different story. They tell us we were wrong. So the evidence is clear. The history is written in the trees, and the potential is confirmed out there in the stars. These giant solar storms are not a question of if, but when. The only real question left is, now that we understand the true power of our sun, will we be ready for the day it wakes up?